Welcome. We are presenting a question that was done in KCSE 2001 paper 1, a question on matrices, form 3 mathematics. And the question we have reads, given that matrix P has elements 2, 1, 3, 2, and Q 2, negative 1, negative 3, 2, find matrix product PQ. Hence, you solve the simultaneous equation below. We are first going to begin by multiplying P and Q, and P is 2, 1, 3, 2. We multiply by Q, which is 2, negative 1, negative 3, 2. Remember, we multiply row times column, so we are going to begin with the first row, then first column, that is 2 times 2, you get positive 4, 3 times negative 1, you get, that is plus negative 3. Then the first row times second column, that is 2 times negative 3, giving us negative 6, plus 3 times 2, giving us positive 6. Then 1 times 2, you get positive 2, plus 2 times negative 1, you get negative 2. Then 1 times negative 3, you get negative 3, plus 2 times 2, giving us 4. This one is going to give us 4 plus minus 3 will give us 1. Minus 6 plus 6, you get 0. Then 2 plus minus 2, you get 0. Negative 3 plus 4, you get positive 1. And that is the product of PQ, which is actually the identity matrix. Having done that, we now move and work on the simultaneous equations that we have. And the simultaneous equations we have is 2x minus 3y is equal to 5, and minus x plus 2y is equal to negative 3. We are first going to start by writing them in matrix form. That is, from the first equation, the coefficient of x is 2 and the coefficient of y is negative 3. In the second equation, the coefficient of x is negative 1 and that of y is positive 2. Then we have xy, and this one is going to be equal to 5, negative 3. 5, negative 3. After that, we usually get the determinant of the matrix by multiplying the elements in the main diagonal, that is 2 times 2. We minus the elements in the other diagonal, which is negative 1 times negative 3. This one is going to give us 4 minus negative 1 times negative 3, you get negative, that is positive 3. And this one is going to give us positive 1. Once we have gotten that, we next get the inverse. The inverse is going to be 1 over the determinant, which is 1 times. Now we interchange the elements in the main diagonal. That is where we have 2 goes to where we have 2, and therefore since they are the same, we are going to have 2, 2. Then we interchange the signs of the elements in the other diagonal. We are going to have 2, positive 1, then 3, 2, as the inverse. Once we have the inverse, we can now multiply by the inverse on both sides of the equation. That is 1 over 1 is 1, and therefore the inverse is going to be 2, 1, 3, 2. We multiply this by 2, negative 1, negative 3, 2, xy, and this one is going to give us the inverse, which is 2, 1, 3, 2, multiplied by the constants, which is 5, negative 3. From there now, if you multiply the matrix times its inverse, it will always give you identity matrix, and therefore we don't multiply. On this other side, we have x and y. I'm saying we don't have to waste a lot of time multiplying what is going down to identity. And this one is going to be equal to 3 times 5, you get 10, plus 3 times negative 3, you get negative 9. And of course, 1 times 5, you get 5. Plus 3 times negative 3, you get negative 6. This one is going to give us 10 plus minus 9 is 1. 5 plus minus 6, you get negative 1. That means xy will be equivalent to 1, negative 1. That means x will be equal to 1 and y will be equal to negative 1. And that is the answer to this particular question. Thank you for watching and welcome to our discussions. And in case you are watching this channel for the first time, please take a second or two. You click the subscribe button so that anytime we publish a video like this, you will automatically be given a notification. Thank you and welcome.